Okay, welcome to another Rust tutorial. Today we're going to take a look at enums. Now, enums are similar to structs. Structs gives you a way to group data as fields, while enum will give you a way of saying that a variable or a value could be one of these possible values. So for example here, let me define an enum. We define that by using the enum keyword, and I will call it direction kind. So this enum will hold all the possible directions that we are defining here. Let's say you are building a game and then the character will have to move in certain directions. Okay, so first will be east. Now the directions can either be east, west, north or south. Now, but how do we use it? Let's say inside main we have a variable that we call, let's say, direction kind 1, and then we set that to direction kind. You have to use one of these values. So we are now saying that this value, okay, this variable will hold one of these variants of this enum. So each of this arm of an enum is called a variant. So let's say in this case we say it will hold east. You assess that using the double semicolon, as if you are assessing an associative function in a struct. If you want to know more about associative function, check out this video that I just made explaining it. Now we are done. So we have said this value, this direction kind 1 will be of type direction kind, and then we provide one of the values. Now pay attention to a few things. We can't just say it's going to be one of these. If you've come from other languages, you should know how to use the enum. Okay, we can't just say it will be this type, but it has to be one of these variants. So that is why we have to provide one of them, and in this case we chose east. So the character will have to move east if it means this kind. Of course, you can also switch it up to something else. You can say west. And one thing you will notice here is that this direction kind 1 will be of type direction kind, but for each of these west, east or north we use here, it will still accept it because they are valid kinds. Okay, so we've successfully defined that these will be of different kinds, one of different kinds. Now, as you know, Rust has some kind of radical ideas, you know, especially if you look at it from the perspective of other languages. In many other languages, enums are just types. Okay, in JavaScript, once you define this, it will just assign its own numeric values to it. But you can even do more with enums, and this is part of why we treated structs first, because they are quite similar and we have to differentiate them really well in order to prevent confusion. Now, one thing you will notice here is that in this game we are building, or pretend game we are building, let's say this value or the character has to move in this direction, and at this point it's holding direction west, but we still have to provide how long it has to go. So how far west should it go in meters? Okay, now our first instinct might be to create a struct that will hold it. Okay, let's say we have a struct we call direction. Okay, now let's say this will hold far, which will be of type let's say f64. And now, in order to tell the character to move a certain direction of this direction kind by a certain meters, we will then use this new struct we created. We can say let direction. So this is the direction it's going to move. It will be of type direction. By the way, if you want to know more about structs, I've also done a video. You can check it up right here. It will pop up in your screen. We can explain in detail how structs work. So you can say this will be a direction, and then we create the direction, an instance of the direction, and then we say it will go 34.4 meters west. But again, we still have to provide where it has to go. In this case, we can then provide a kind of direction kind. You can say direction kind and then we say it will be of type direction kind. Okay, then we'll have to provide the kind here, of course. You can then say it will be direction kind will be east. Okay, so this way we can now comment that. This way we can say give the character this direction, and then the character can detect where it will go. It will go due east, and then it will move by 34.4 meters. But this is not the most simplest way to do it in Rust. Rust gives us more features to simplify this, and that has to do with the other powers Enum has. Now, not only are you able to define variants of enums in Rust, these variants can also hold some value, okay, which is quite different from other languages. In fact, I've not seen other languages that does behave this way. You can say that this direction kind will also hold a string type. Okay, now what it means is that whenever you are creating this type, you also have to provide how far it has to go, because of course that is what happens. You can't just provide where you have to go, you also have to provide how far you have to go, and this will make it a lot easier for us. In fact, we can even remove this struct, okay, that is defining the direction, because it's no longer needed. You can just comment it out. So comment code in Rust, all you have to do is to prefix them with this double forward slashes, and then coming down here we can also comment this one because we no longer need it, and we can now reuse the first one, except that if it is east, we have to provide how far east. Okay, in fact, let's change that to, instead of string, let's change it to F64, and then we can go back here and then provide how far it has to go. You can say it can go 44.0 due east, and we are good. So we've eliminated the need to have extra structs and extra unnecessary codes by simply providing the type of value this enum variant we have. So not only can enums provide the different types you can have here, like east, west, north, and south, but you can also provide the values. You can also hold some values inside, and you can even do more, as I'm going to explain in a second. Okay, I guess you can start appreciating the values or the features that Rust brings to the table. Now, there is something else I need to point out. It might be very obvious, but let me still explain it. Each of these variants implicitly gives you the ability to construct an instance of this. So they all act as constructs to create an instance of this direction kind. In fact, that is exactly what we did here. We called east as if you're calling a function or a constructor that returns a kind. And you can see that after creating this, whatever it is that we returned here was accepted as the value that will be stored here. And since we've defined that it must be of direction kind, and Rust is happy with it, it means that whatever all this returns is an instance of this direction kind. So each of these variants we add as a constructor to construct an instance of this. And you might be asking, why am I calling it instance, as it is not a struct? But it's kind of what it does. It returns an instance of this. An instance is just a representation, a creation of it. Now it's important to notice that Rust even accepts all kinds of things. Okay, so in this case, it doesn't just only accept primitive types like F64, it can even accept struct types. Okay, for example, I can say here that west, whenever it is called, that it will accept type of direction, which is a struct. And all I have to do is to provide it here. Okay, but we have to remove that. If not, it's going to cause some errors. Okay, but this defines, or this demonstrates that each variant of an enum can accept all kinds or all types. It can even accept enums, structs, primitive types, strings, and all that. And then, as you've noticed, this is not like an array. Okay, it's more like a tuple, in the sense that each variant can accept different types of data. For example, here this one is accepting F64, okay, but this one is accepting the direction struct. Okay, this one doesn't even accept any value, which goes to show that each of them can behave differently and accept different values, and then you can work with them differently as well. For example, in the game you are building, you could say that whoever is going west can move not just to a particular point but to a range of points, and that means you can provide a tuple as the type you will accept by saying it can accept a range. Let's say this will be the starting range, and then the second value will be the stopping range. Now this west variant will accept a tuple of these two values, which will represent the range that the character could move due west, while the east remains just one value. Another benefit you get with enums is that, let's just remove this, is that it simplifies our code, as we've just demonstrated in the previous one, where you, instead of creating a separate struct, okay, you could just allow this variant to accept a value. Enums also makes it a lot easier for us to use less structs. So instead of creating lots of structs, one for east, one for west, and defining the fields it will accept, and then another one, maybe a unit like struct that will not accept anything, we can just use one enum to incorporate all of these, and then if they are going to accept some values, we define them here and then accept them. It makes your code a lot cleaner, as you'll be using less struct. Now here is another radical thing that an enum can do. So we've seen that each variant can accept a value. You can also create methods for an enum, okay, just like a struct, by using the implementation keyword, just like for a struct, and then you start defining the functions. You could say, let's say this enum will be print east. Okay, now we want to make this a method, so we provide self. Okay, and so to print that, now to access the value from this direction kind, we have to do something a little bit different. Okay, we use the match expression. Now this match expression is like switch case in other languages. Okay, it's a little bit like an if statement, where we want to say when the value is east, we do something; when the value is west, we do something; when it is north, we do something else; when it is south, we do something else, such as similar to a switch case statement. Now this is very, very important, and this is one of the ways Rust makes sure that there are no errors. Whenever you are doing something like this, it will encourage you, Rust will encourage you to match all the different variants, because it could be any of them. So we define the match arms for each of these variants. So for east, you can see here that east accepts one parameter, okay, and that is what we accepted here, and then we're able to print it here. So the first thing you have to notice is that we define the match keyword, and then what we are matching is self. This self represents this direction kind, and then we open these curly braces. Inside here we will provide some code to match all the variants. Okay, we started with the east, and the east accepts one value here. We got that value here, and then defined a code block where we can handle the value as if it's a function. Okay, and then inside here we were able to obtain far, and then print this far meters due east. You can see that west here accepts a tuple value, and that's exactly what we did here. We destructured the tuple from here, and then we can use it inside this code block right here. Something for the north. The north, you can see that it doesn't accept any value. Okay, and here we didn't need to read the value from it. We left that open, and then we can just do anything for this north, for when self is equal to north and all that. So this way we can easily use this method defined for this enum to do something. In fact, let's try it out. Here we define this value, okay, and then we say we are going due east, and since we already have inside this method we have something to print for when the kind is east. We can easily come in here and then say direction1 dot print east. Okay, and now all of a sudden we are calling print east, which is a method on this enum, and in fact when we run that code you get 44 meters due east, which is exactly what we provided here. Okay, now I know this might be a radical idea in some ways, because in many languages you can't create a method for an enum. You can't even provide the value that an enum variant could hold, but it's totally possible in Rust, and this is exactly how it works. You can use that, it works really well. Now in subsequent videos I'm going to explain many other things you could do with this enum. As you already know, Rust doesn't have the null type, okay, and it uses enum somehow to make sure that some silly errors you get in other languages due to your variable holding null does not occur in Rust. Okay, and we're going to explain how the enum options take care of that in another video. So make sure you get subscribed so that when we release that video you get notified. Thank you.